Hello students, once again this is Shashank Sapra, and today I am here with a new video to explain you, to describe you the various interesting facts and the various kinds of solutions that are found in our surroundings. Yes, we are going to start our second chapter of chemistry section, that is matter around us pure. In the previous chapter of chemistry, we studied about what is matter and what are the properties of matter. And now we will study the classification of matter and the different kinds of matter and solutions. Alright, so let's get started. Let us move to the chapter. First of all, we will be studying over here that what do we mean by a pure substance, or what do we mean by purity. Right? In general terms, for us, purity means something that is fit for consumption. Right? As a general public, or as a normal consumer, what we think is something that something which is fit for consumption, that is pure. But when we see when we go through the scientific point of view, then pure means something that is in its purest form, or we can say a pure substance is a homogeneous material in which all the particles are of similar kind and have a definite property. Right, so purity in science means something else. You can see over here, a pure substance consists of a single type of particles. In other words, a substance is a pure single form of matter. Right, now the next thing is, what is a mixture? So mixture is a combination of two or more pure substances in any ratio. Whenever two or more pure substances are mixed with one another in any ratio, then that is referred to as a mixture. Right, and when we study the types of mixture, then we come across two kinds of mixture. The very first is a homogeneous mixture, which has a uniform composition throughout its volume. For example, a sugar solution in water or a salt solution in water. And when we come across heterogeneous mixtures, then these are the mixtures which have a non-uniform composition in their volume. That means different parts or different portions of that mixture will be having different kinds of properties and different kinds of composition. For example, a mixture of oil and water is an example of heterogeneous mixture. Right, now after that we come across a solution. So now what we have to see is, what is a solution? A solution is a homogeneous mixture of two or more substances, like the one we come across daily in our life. कई सारे ऐसे solutions हैं जिनके across हम daily आते हैं, like a sugar solution, a salt solution, a lemonade, soda water. These all are solutions of two or more substances, and the solution is a homogeneous mixture. That means you can say a homogeneous mixture is actually a solution in which the two or more substances are mixed with each other in any ratio. They can be mixed in any ratio with each other. Right, other than this, a different kind of solution are alloys. Alloys are mixtures of two or more metals or metals with a non-metal. Right, and because these are the mixtures of metals and metals or metals with non-metals, they cannot be easily separated into their constituents by physical methods. But alloys are very useful in our daily lives because they are mixed by combining two or more metals, and the alloys arise as a result of this mixture are entirely a set of different properties. इनसे जो properties हमें मिलती हैं वो entirely different होती हैं. For example, over here an example is discussed, brass. Brass, which is a mixture of 30% of zinc with 70% of copper, and it has entirely different properties and entirely different color from both of them, that is from its constituents zinc and copper. Similarly, bronze is also an alloy made up of copper and tin. Right, amalgam is also an example of alloy. Solder is also an example of alloy. So there are very examples of alloys you will find out around you. Now let us study about the components of solution. So whenever we talk about a solution, mainly there are two components necessarily in a solution. The one which is present in a larger amount or in a larger proportion, that is referred to as solvent, and the other component which is present in a smaller compound or a lesser proportion, that is known as solute. बेटा किसी भी solution में आपके अगर दो components की हम बात करें और दोनों में से जो component ज़्यादा amount में है, that is called as solvent, and the other component which is present in a smaller amount, that is referred to as solution. You can see over here that is referred to as solvent. The amount which is the substance which is in the larger amount is solute, and the substance, sorry, I would let me correct myself. The component of solution that is present in a larger amount is called solvent, and the component that is present in a smaller amount is called solute. For example, if we talk about salt solution in water, then salt is solute and water will be acting as solvent, right? There are certain examples given over here. यहाँ पे कुछ examples भी हैं solution के, like a solution of sugar in water, a solution of iodine in alcohol, aerated drinks like soda water, and air is also a mixture of gases. So let me tell you, beta, mixtures can be of any type. Like we have dealt through the mixture of solid into liquid, है ना? Solid into liquid का अगर हम mixture देखें तो salt and water. If we talk about liquid mixture, then also iodine and alcohol. If we talk about a gas into liquid mixture, then aerated drinks like soda water. CO2 gas is usually pressurized into the liquids before packaging of bottles. And if we talk about gaseous into gaseous mixture, we can talk about air. And if we want an example of solid mixture, then we have just gone through the alloys. Alloys are a mixture of solid into solid. So that is also an example of solution, right? Now let us move towards these properties of a solution. That is the most important part. The solution is a homogeneous mixture So the solution is a homogeneous mixture, and the particles of a solution are smaller than 1 nanometer, that is 10 to the power minus 9 meters, and therefore they cannot be seen by naked eye. Because of their very small particle size, the particles of solution are not able to scatter the beam of light passing through it, and therefore the path of light does not becomes visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. Because they do not settle down when left undisturbed, therefore the solution is usually stable. Right? Stable means the solution is having a constant uniformity even when it is left undisturbed. Right? Now let us talk about the concentration of solution. If we have to find out the concentration of of a solution, then we can do so by different methods depending on the nature of solute and the solution. Right? For example, if the solute is a solid, then we can find out mass by mass percent of a solution, mass by mass percentage of a solution, in which mass of solute divided by the mass of solution into 100 gives us the percentage concentration by mass. Right? If in case the solute is a solid substance whereas the solvent is liquid, for example salt and water, we can find out the mass of solute the divided by volume of solution into 100. That means this is mass by volume percentage. And if both the components, that is the solute and the solvent, are liquids, then we can calculate the volume by volume percentage of a solution. So these are the three methods of finding out the concentration of a solution depending on the nature of solution, whether it is nature of solute, whether it is solid, liquid. We can we can decide the formula to be used over there, right? There are certain examples in the NCERT also, by the help of which you can just get a clear or get a better understanding of these questions. Now let us talk about suspension. So let me tell you, suspension is a non-homogeneous system. That means it is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended in the bulk. यहाँ पे dissolve होने का मतलब क्या है? They have not having that kind of solubility. If a suspension is left undisturbed, then the solute particles will settle down. That means it is unstable, and particles of a suspension are visible to naked eye. That means they are bigger enough. So if we talk about the properties of suspension, suspension is a heterogeneous mixture. The particles of suspension can be seen by the naked eye. The particles of a suspension scatter a beam of light passing through it and makes its path visible. The solute particles settle down when a suspension is left undisturbed. As I told you, the suspension is an unstable mixture, therefore the solute particles will settle down and they can be separated from the process of filtration process से simply हम एक suspension को separate कर सकते हैं, उसके components को we can separate out. When the particles settle down, the suspension breaks and it does not scatter light anymore. Remember, suspension scatters the beam of light. It also sometimes makes the path of light visible to us, but till the time the suspension is stable, Once the suspension becomes unstable, that means once the suspended particles gets settled down at the base of container, it is no more suspension. तब वो suspension नहीं रहा, and then it will not scatter the beam of light. Okay. The third kind of mixture we have to study over here is a colloidal solution. Colloidal solution, let me tell you, is a one more heterogeneous system which appears to be homogeneous, right? But let me tell you that it is heterogeneous, and the colloidal particles are usually smaller in size and not visible by the naked eye, but they are not that small that they cannot even scatter the beam of light. So the particles of colloidal solutions are not visible by the naked eye, but they scatter the beam of light to show an effect known as Tyndall effect. Right? Tyndall effect is an effect in which a cone-shaped pathway of light is visible within the colloidal solution. The effect got its name from the scientist who discovered this effect. Properties of colloids. The very first property of colloid is a heterogeneous mixture. The size of particles of colloid is too small, as I told you, to be individually seen by the naked eye, whereas the colloidal particles are bigger enough to scatter a beam of light passing through it. They do not settle down when left undisturbed. That means the colloidal solutions are also stable, just like true solution. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the constituents of a colloidal solution. Right? And let me tell you one more thing. As we studied in the case of solutions, the component that was present in a smaller amount was known as solute, and the component that was present in a larger proportion was referred to as solvent. Similarly, over here, in the case of colloidal solutions, you can replace solute with the dispersed phase and solvent by dispersion medium. Over here in colloidal solutions, the medium in which something is dissolved, that means I can say the dissolving medium is called dispersion medium, and the dissolved substance is called dispersed phase, right? So this is all about the colloidal solutions. There are certain examples given in your NCERT books for colloidals in which liquid gas, solid gas, colloidal solutions are given, so you can get a look over it. Now the next part of our chapter discusses the separation of components of a mixture by different methods depending on the properties of components of a mixture. Guys, किसी भी मिक्सचर के जो कंपोनेंट्स हैं उनकी प्रॉपर्टीज पर डिपेंड करते हुए वी विल बी फाइंडिंग आउट डिफरेंट प्रोसीजर्स, डिफरेंट प्रोसेसेस टू सेपरेट द कंपोनेंट्स. Like the very first case discussed over here is the case of separation of colored compound or colored component from a blue black ink. So in this condition we will be using the process of evaporation, in which first of all in a china dish we will be taking ink and we will be heating this china dish by the action of steam. In a beaker some amount of water, as you can see in the figure, is taken, and when this water evaporates the steam rises up, and these water vapors or the rising steam heats the china dish from its bottom, and ink is placed in the china dish. After some time water content the water component of the ink will evaporate, and in the china dish you will be finding out the colored component separated out, because the water is highly vaporizable. It will boil and evaporate at 100 degrees Celsius of temperatures. In this way you can separate the colored component from the ink. The next article, article 2.3.2, discusses how we can separate cream from milk. So let me tell you, that is a very common process these days. Even the humans have been using this process for so many years of, or we can say for so many ages, for separation of cream from the milk. And the process is centrifugation, right? In our daily life activities or in our common language, we usually say it mathni, है ना, मक्खन को मथा जाना. But let me tell you, the centrifugation is not a household activity now. ये एक household activity नहीं है. The centrifugation process is now being utilized in big industries like Amul's for separating cream from the milk. And the application of this process of centrifugation has so much importance in the industries that because of this process only you are getting your cream, toned milk, double toned milk, and butter and other dairy products to your homes. Right? Now, The next procedure of separation is how can you separate a mixture of two immiscible liquids. So for separating two immiscible liquids like a mixture of oil and water, you have to use a separating funnel. Whenever a mixture of two immiscible liquids is kept into a separating funnel, this separating funnel when left undisturbed creates two different layers of the liquids. Then at the bottom there is a stopcock by opening which you can get the bottom layer out of the separating funnel, and in this way the two layers are separated from each other. The next way of separation is for separating a mixture of salt and camphor. So let me tell you that among the salt and camphor, camphor is a highly sublimable substance and becomes and changes into gaseous state on heating without coming into liquid state. So if we will be heating a mixture of salt and camphor, then the vapors of camphor will rise up and these vapors will be collected on the inner side of inverted funnel as you can see in the setup, and within the china dish your salt will be remaining as residue. In this way the salt will be remaining in the china dish and the camphor can be obtained from the inverted funnel. Alright, so sublimable substances can be separated in this way from the non-sublimable substances. ये प्रोसेस तभी वर्क करेगा गाइस जब आपके मिक्सचर में दो में से एक कंपोनेंट सब्लिमेबल है और दूसरा सब्लिमेबल नहीं है. रिमेंबर दिस थिंग. Now the most important matter 2.3.5, that is how we will be separating the colored components from an ink. If an ink contains more than one colored component, then how can we separate it? So remember, for separating different colors from each other, or for separating colored pigments from a solution, we have to use a technique known as chromatography, also referred to as paper chromatography, which is based on the principle that different solutes in a solvent have different levels of solubility, and depending on these solubility, different components will show different level of marks on the filter paper, right? The activity is given in 2.7, which is very good, which is elaborated in a very good way. Let me tell you in the activity, first of all, we will be taking a filter paper and making or drawing a line from the bottom at 3 centimeters. Then on this line you have to put a spot of ink, and remember the ink should be water soluble, right? Let us imagine that this ink contains three colored components which are of different colors and they will be having different solubilities in the water. Now we will be keep this filter paper hanging into a beaker filled with water up to some extent. The water should not touch the mark of pencil, and when this filter paper, as we know filter paper is an absorptive sheet, it will absorb water, and once the water crosses the ink mark, it will dissolve the colored components of ink, right? After some time of leaving it undisturbed, you will be finding different patches of colors on the filter paper. The patches that will be find on the highest position will be having maximum solubility in water, and in this way you will be able to see the different components of colors in the ink. Different colored patches will show different components at different levels on the filter paper depending on their solubilities in the solvent. The next method is to separate a mixture of two miscible liquids. Remember, whenever two miscible liquids that are highly miscible or soluble with each other, you can separate these kind of mixture by using a distillation apparatus. In a distillation apparatus, you need a distillation flask fitted with a thermometer so as to check the temperature. And on the other side, there is a condenser which condenses the vapors of one of the component and collects it in the beaker. Actually, the distillation apparatus the distillation process is based on the procedure that out of the two miscible components of mixture, one of the component will be having a lower boiling point than the other. The component which will be having a lower boiling point will be converted into vapor state first, and then we will be condensing these vapors through the condenser and collecting it in the beaker on the other side. In this way, the highly vaporizable substance will be collected in the beaker, and the substance which have a high boiling point will remain in the distillation flask. An advanced procedure that is known as fractional distillation is also used when the components of mixture have a difference in their boiling points less than 25 Kelvin. In this condition, within the distillation apparatus, a fractionating column is also increased or adjusted which contains glass beads to increase the surface area, right? So fractional distillation is just the advanced kind of distillation which is used when the two components of a mixture have a difference in the boiling points less than 25 Kelvin. Now there is a method to obtain different gases from the air. As we all know that air is a mixture of different gases and different ratios, which usually contains 78% of nitrogen, 20.9% of oxygen, 0.9% of argon, and they all have different boiling points, right? So if you want to separate a particular kind of gas from the air, so there is an apparatus given over here. You can see. Let me explain you stepwise. First of all, let me tell you, this is an apparatus to separate oxygen from the air. In the present case, we are going to separate oxygen from the air, but it is not so. You can separate any of the gas from it, right? So first of all, there is a filter. As you can see, from the filter, the air is filtered out and is inserted into the setup. As and when the air is entering into the setup, there are two pistons that are creating a pressure over the air to compress it. That means the air is compressed at the very first stage. Now, as and when the air is compressed, the temperature of air rises up and this hot air is now passing through a condenser. A condenser is a chamber with spirally coiled tube which continuously runs cold water in it. Because of this cold water, the chamber becomes cool, and at this low temperature, the hot air suddenly gets cooled down and is somehow liquefied. The air is now cooled down, and this is now referred to as cold and compressed air. This cold and compressed air, you can see, is now transferred into a separator. The separator separates out carbon dioxide from the air as dry ice. Dry ice is the solid form of CO2. From the separator, the gas passes through expansion jet and finally into a fractional distillation column where the nitrogen and argon is separated out from the air at different heights, and finally in the last stage, in the last chamber, you have liquid oxygen with you. So this the complete procedure was to separate out liquid oxygen from the air. All right. Now let us see how can we obtain pure copper sulfate from an impure sample. So for this we have to carry out a procedure called crystallization. First of all, we will take some copper sulfate and mix it with water. Then we will filter the impurities out of it and evaporate water from the copper sulfate solution. After this, we will have to keep this solution undisturbed for about 1 day. After 1 day, crystallization process will take place and you will be finding the copper sulfate crystals in your china dish. The crystallization method is used to purify solids which usually have some impurities embedded in it. The salt we get from the seawater can have many impurities in it. To remove these impurities, the process of crystallization is used. Crystallization is a process that separates a pure solid in the form of its crystals from a solution, and the impurities are separated out. Now there is a topic why crystallization technique is better than simple evaporation. So first of all, some of the solids may get decomposed or charred on evaporation. So for such kind of solids, crystallization is a better technique. Secondly, some impurities may remain dissolved in the mixture even when evaporation is taken out or carried out. Therefore, crystallization works well over there. All right. Now let us see. There is a process in which the book is discussing the about the process that is followed by the municipality to give us the supply or to ensure the supply in our homes free from germs, right? The water works department follows a particular process or procedure to ensure that the supply that we are getting in our homes of water should be free of germs and should be healthy or potable. So first of all, we can see in the setup there is a reservoir in which the water is first of all collected, and then it is passed through a sedimentation tank where the solids are allowed to settle down, and finally some of the suspended impurities are allowed to settle down in a loading tank. तो यहाँ पे 3 stages हैं. First of all guys, reservoir जहाँ पे water को सिर्फ collect किया जा रहा है from the source. Then sedimentation tank जहाँ पे impurities को settle down होने दिया जाएगा, means in the sedimentation tank water will be somehow remain undisturbed for some time. कुछ समय तक water को sedimentation tank में रखा जाएगा. And then the second is loading tank, which allows suspended impurities to settle down. And after both these stages, the water is transferred into a filtration tank where the water is filtered by the natural process, that is the fine sand, gravel, and the coarse gravel. When the water passes through these different layers, then the impurities get entrapped within these layers, and the pure and filtered water is now transferred into the other chamber where chlorination is going on. Let me tell you, chlorine is a disinfectant with water, and chlorine tablets are usually added before the supply of water to our homes so as to ensure that there should not be any kind of infection causing bacteria remaining in the water. Finally, after chlorination, the water is now supplied to our homes, which is usually fit for drinking, right? So in this way, the municipality ensures that each of the citizen of country is getting pure drinking water at their homes or at their places. Now the next heading that we are going to discuss is physical and the chemical changes. So let me tell you, physical changes are those changes that usually occur in the physical properties of a substance like color, shape, size, melting point and boiling point, etc. Whereas the chemical changes are the one which usually occur as a result of chemical reaction, and they cause a permanent change in the properties of substance. Usually a chemical change is a permanent change in the property of a substance, right? Chemical changes usually takes place as a result of chemical reactions. Now the next thing is, what are the types of pure substances? So let me tell you, pure substance is usually divided into two types on the basis of their chemical compositions. The one is elements and the other is compounds. Elements term was very first used by Robert Boyle in 1661, and element was finally defined by Antoine Laurent Lavoisier. He defined element as a basic form of matter that cannot be broken down into simpler substances by the chemical reactions. We can find out 100 to 120 elements in our periodic table approximately, and these elements are divided into three types, like the metals, non-metals, and the metalloids. Metals are the one that usually have a luster. They conduct heat and electricity. They are malleable, they are ductile, and they are sonorous. Whereas non-metals do not possess these properties. They usually are poor conductors of heat and electricity. They are not malleable, non-ductile, non-sonorous, and they display a variety of colors. Other than this, most of the metals in our periodic table are solids except mercury at room temperature, which is liquid. Most of the non-metals usually are electronegative in nature, right? Examples of some of the non-metals are hydrogen, oxygen, iodine, carbon, bromine, chlorine, etc. Let me tell you, bromine again is a non-metal which is liquid at room temperature. And when it comes to metalloids, then metalloids are those elements which have or which exhibit properties of both metals as well as non-metals. Some of the characters of their uh, exhibit similarity to the metals, and the other characters exhibit similarity to that of non-metals. Therefore, they are referred to as metalloids, and they also show a transition of metals into non-metals. Examples are silicon, germanium, and boron. Then comes compounds. Compounds are substances which are formed by combining two or more elements in an appropriate ratio. Whenever two or more elements combine with one another in a fixed ratio, then a compound is formed. For example, let us take the example of H2O, water. Then in H2O, two atoms of hydrogen always combine with one atom of oxygen to give H2O. So it is a specific compound. Whenever we talk about water, then we refer to H2O and not HO2. So H2O is an appropriate compound with a fixed ratio of hydrogen and oxygen atoms, right? Over here, you can see a very good differentiation of elements and compounds. Elements or compounds just mixed elements or compounds, there's a differentiation between mixtures and compounds over here. Let me tell you, elements, if you want to know about the differences between elements and compounds, so element is a undivisible unit of matter, whereas compounds are mixture of two or more elements. It's just simple. And when we talk about mixtures, so elements or compound just mix together to form mixtures, and in no new compound is formed. Whereas in the case of compounds, elements combine or react with each other to form new compounds, and these compounds usually have entirely different properties from that of elements. For example, if we talk about hydrogen and oxygen, then both are somehow supporting combustion. Hydrogen on one hand is a very good fuel. Oxygen supports combustion. When they combine with each other forms H2O, which is a fire extinguisher. So you can see how the properties of compound changed when they are formed by combining elements. A mixture may have a variable composition, but the composition of each new substance formed or compound is always fixed, like H2O, CO2, C6H12O6, NaCl, HCl. These all are compounds and have a fixed ratio. A mixture shows properties of the constituent substances, but the new substance formed as a compound is finally and is entirely different from its constituent elements. The constituents can be separated fairly easily by physical methods in case of mixtures, but in case of compounds, the constituents can be separated only by chemical or electrochemical reactions, right? So it is a bit typical process. Finally, on the last page of your chapter, before summing up, there is a very good flow diagram or a flow chart to indicate matter. We can see matter, which can exist in three physical states: solid, liquid, and gas, is further divided into pure substances and the mixtures. When it comes to pure substances, these pure substances may be of two types, either element or compounds, whereas mixtures can be of two types, homogeneous and the heterogeneous ones. So I hope the chapter was all clear to you. You are now left with no doubts regarding the chapter. I have tried to give you the full content along with necessary information of this chapter. Thank you, students, for your support, for your love. Stay safe, stay healthy. Good luck, everyone.